What do you do when the world's hottest trend, AI, is making everything even hotter? Well, today, thankfully, we're going to be cooling the room with my guest, Todd Grabowski. He's the president of Global Data Center Operations at Johnson Controls. And he's a career tech expert who has spent decades figuring out how to keep our digital lives from melting. So if you've ever yelled at a laggy video call or waited for a file while your laptop spun like a tiny jet engine, you've felt a sliver of the same physics at play inside the deep, dark, hyperscale data centers around the world. Because, hey, chips are getting faster and heat keeps piling up. And somewhere an engineer has to move that heat without burning through the power or precious water supply. And that's where advanced HVAC and liquid cooling step in. He leads teams building systems that sip energy, recycle water in closed loops, and keep servers humming through heat waves that would frighten an ice cream truck. And yeah, we'll also talk about magnetic bearing compressors, water-free cooling, and why better heat transfer isn't just a geeky side quest, but a performance story for every business that is currently betting on AI. So, if AI is the brain of modern tech, then cooling is the circulatory system that keeps it alive. So, are you ready to hear how smarter cooling boosts speed, uptime and sustainability without turning the planet into a sauna? Well, hopefully you are. So it's time for me to officially introduce you to Todd now. So a massive warm welcome to the show, Todd. Can you tell everyone listening a little about who you are and what you do?
Sure, Neil. So first off, thank you for having me. It's great to be here today, certainly in a very exciting time within the industry and within Johnson Controls. So I'm Todd Grabowski. I have the privilege of leading the Johnson Controls Global Data Center Solutions business, really which aims to meet the global demands that we're all seeing, the boom within the data center industry. And we're trying to meet those demands really threefold. We're trying to do it with scalability, innovation, and consistency, so we deliver consistent results to our customers across the globe. But I also have the privilege of leading our global applied HVAC equipment business. Those two are very tied close together, as well as I'm sure we'll talk about how we're meeting cooling demands. On the HVAC front, on applied, we're really focused on innovation. Energy efficiency and sustainability are the key drivers of our equipment business, which of course tie in very nicely into how we're trying to solve our customers' problems on the data center side.
And you said it's an exciting time. It really is. I've been to a few tech conferences lately. There is this huge push away from public cloud back to private cloud and on-prem, which everything's coming full circle. And I also believe congratulations are in order as Johnson's Controls is celebrating 140 years this year, which is phenomenal. A big year for you, right? But what is it you're most proud of in your work at Johnson Controls right now?
Well, I mean, so really, and there's actually two celebrations for us. It is a big year. So Johnson Controls is celebrating 140 years. And then, one of our flagship brands, the York brand, which is our leading brand within applied and thermal cooling, the York brand is celebrating 150 years. And so I've had the privilege of being with the company now my entire career, over 30 years. And really, when I think about my career, I came in to Johnson Controls in York 30 years ago, right when the industry was shifting away from chlorofluorocarbons, what they called CFCs. So in the refrigerant world, those were refrigerants like R12 in refrigerators and automobiles, and R11 in some of your hospital and school applications that really had harmful characteristics to the environment. And so, when I joined 30 years ago, we were shifting away to a more sustainable refrigerant. And now here we are, 30 years later, and we're using those same muscles that we've been doing for over 30 years now as we're launching our next generation of, ultra low GWP refrigerants. And so I think what excites me is, over my 30-year career, it's always been about the same things. It's been about energy efficiency, reliability, and sustainability, and our ability to provide those solutions at scale to our customers has really been the key to my 30-year career, and really the past 140 years of Johnson Controls, and I'm sure going to be the next 100 years of the company as well.
Fantastic news. And although we're recording this episode in September, I think one thing we both have in common, despite being, 3,500 miles apart and a huge pond in between us, is we've both seen a huge heat waves over the summer period. And although we focus on keeping ourselves cool, one thing we don't talk about enough in this AI-obsessed world is how the tech companies that we all rely on are keeping their data centers cool. So can you tell me a little bit more about the scale of this problem? Because it's something we don't talk about enough, I think.
Well, so when you think about this data center boom, there's really two main constraints to this, and it's how do you power a data center, and then as you power a data center, these chips now are generating an absolute ton of heat, no pun intended, and so how do you then dissipate that heat and cool that data center to keep those chips running efficiently? Those are the two problems that really, our industry is trying to solve. And so, from a Johnson Controls perspective, we are really optimizing how we're cooling not just the chip itself, but really now the entire infrastructure of that data center. And so that problem is not unique to a company or to a geography around the world. It is a global situation. And so, we're looking at solutions right now on how we could optimize that cooling platform, from the chip to ambient. And, we could throw out some stats here, and they're really incredible. When you think about a data center, 40% of the energy that a data center consumes is used just for cooling, not for computation. So when you think about the opportunity then to reduce the power demand of a data center, the biggest lever you could pull is how can you optimize your cooling platform? And that's really where Johnson Control comes in, with our vast array of solutions on what can we do to provide the right equipment and then the right optimization and control of that equipment across that cold chain to drastically reduce that cooling demand of power to cool that data center. And that's what we'll be talking about, hopefully, more this morning on the call.
And before talking to you today on this podcast, I was reading that to keep these chips running efficiently, that we're all talking about, and stopping them overheating, your engineers are developing these advanced cooling systems through HVAC technology. So tell me more about that, especially for people listening that have not heard of how to keep these chips cool.
Yeah. So when you think about how you cool a chip, there's, as this chip, and the chips have gotten bigger, but they're still relatively small, right? We're talking about a relatively small chip that generates an absolute ton of heat. And so the way data centers were cooled, in the past 5 and 10 and 20 years is you would simply blow conditioned air across this chip to cool it off. The same way, if you're warm and you're sweaty, you turn a fan on, you blow air across you, and it cools you off. But if you were overheated as an individual, simply putting air on you isn't enough. You've got to get some kind of liquid to the skin to cool you off. And the same thing we're doing in chips, right? So you've heard about this transition from an air-cooled data center to a liquid-cooled data center. And really what we're doing now is liquid is a better heat transfer medium than air is. So now we could take conditioned liquid to a chip and then capture the heat off the chip into a liquid, and then simply transfer that liquid into a chiller device that we would provide, and then eventually reject that heat to the atmosphere. So that's kind of the evolution of how chips themselves are cooled. And then really, so it's about what technologies can you deploy across that cold chain to optimize how that performs, so it takes as little energy as possible to capture, transfer, and reject that heat to the atmosphere. And that's really where Johnson Controls comes in. And so today we're using a platform. It's called the York YVAM. It's a magnet. It's YVAM. It's our latest flagship product designed specifically for data centers. But at the core of that product is our York magnetic bearing centrifugal compressor. And this machine consumes 40% less energy than your typical cooling device that's been deployed for the past 5 years. So when you think about how you could reduce the overall demand of power to a data center, applying this type of technology is a great way to do it. And although it's new technology to a data center, that drive line, that heartbeat of the chiller, we designed that in our applied business over 20 years ago and deployed that for naval vessels that needed to have, reliable, ultra quiet, and ultra efficient operation. So that compressor that we're now using for our data center applications had its origins in naval applications of obviously the toughest conditions possible, ultra quiet, ultra reliability had to be at the forefront of that. That's the same compressor we're now using for our mission critical data center customers.
And I think the great thing about this story is it doesn't matter if there's a business leader listening and their information is stored on the public cloud, private cloud, on-prem or off-prem. Someone is challenged with keeping those chips cool. And during a time where AI is hogging a massive amount of resources and energy, how are you at Johnson Controls preparing data centers for the inevitable rise of AI workloads and immersive technologies as well? It's a huge undertaking and challenge, I would imagine.
So it really is. When you think about how we're going to handle this boom, we're really going to be trying to balance, three constraining resources. And when you look at an optimized solution, it's based on how these customers are weighing these three resources. And those resources are land. How much physical land do you have to potentially reject this heat? It is power. How much power is available to you? And it's water. Are you in a water constrained environment that you don't want to consume water? And so you're trying to balance all three of these, resources into an optimal solution. And so when you think about what can Johnson Controls do, our solutions are really designed to maximize the benefits of all three of those. How could we get the most capacity possible? In other words, the most heat rejection off that chip possible in as small of a footprint as possible. That's step one. How do we then utilize the least amount of energy possible to generate the cooling needed for that chip? That's where our YVAM chiller comes into play, drastically reducing the power consumed. And then on the water side, how do we not consume a precious resource like water in that whole loop? And so that YVAM solution that I've been speaking of consumes zero water. So it uses water in a closed circuit loop, but it doesn't consume any of that water. So it is a non-water consuming solution. And that's, we've seen obviously for all three of those reasons, a great migration to this platform and that technology that we're now deploying globally, not just in the US, but globally.
And as you said, zero water there, I can hear light bulb moments going off all around the world. And AI has hit the headlines for the sustainability problems that it poses. So what role does sustainability play in your own product roadmap, especially with water-free cooling solutions that you mentioned, like YVAM, for example? Tell me a little bit more about that.
Well, so, when you think about sustainability, first off, how sustainable are our own operations? And so, we've set our own sustainability goals as a corporation that we're holding ourselves accountable to ensure that we're preaching what we're delivering to our customers. And so we have our own sustainability goals as a company, and we talk about those repeatedly on all of our earnings and public statements. Then number two is how much resources does our solutions then require of our customers? And so that's why when we talk about reducing the amount of energy needed for them, that's a sustainable solution. We talk about then utilizing zero water, that's a sustainable solution. And then we talk about, having our product platform itself with the lowest carbon footprint possible. All of that helps in our sustainability journey. And then we top it off by ensuring that the refrigerant that we utilize within our product is the ultra low global warming potential refrigerant. It's the latest technology in refrigerant solutions. And all of our machines now have been designed specifically for that newest generation of ultra low GWP refrigerants. That's how we provide the most sustainable solutions possible to our customers.
And we're making it sound incredibly easy today, and I'm sure it really isn't. So if we were to take a look under the hood for a moment at all the technology that makes this possible, what challenge did you initially face in adapting magnetic bearing technology for continuous operation in hyperscale data centers, and how did you overcome them? Because I'm sure there was more than a few challenges along the way.
So really, there's two key things that had to get solved. Number one is your typical magnetic bearing machine was designed for water cooled applications, meaning that you typically had a cooling tower consuming water, which means that the compressor itself had a very little amount of lift that it had to overcome. When you're talking about a data center application and you don't want to consume water, we now have to operate that machine in a much warmer ambient environment than it was originally designed for. And so the York YVAM, we've now designed that machine to operate up to 55-degree ambient conditions, meaning that it could still condense refrigerant up to 55 degrees ambient. So that is a technology hurdle that we had to overcome. And we did that through our Johnson Controls Advanced Development and Engineering Center in York, Pennsylvania, where we have over 20 test labs. So we've been constantly testing this technology in those test labs. So step one was, how do we allow that machine to operate in very critical and very warm ambient environments that it wasn't originally designed for? That was hurdle number one. Then hurdle number two is, we've uncovered along with our chip makers that if we continue to raise the water temperature that we supply to the chip, we could continue to make the machine more efficient and drive down power usage. And so what I mean by that is, if a chip used to need, say, 15 degrees C water to make it cool, what we've been able to design and test in our test lab is we could stably run our machine up to 30 degrees C and still provide enough cooling to that chip to keep that chip cool. And so as you raise the chilled water temperature to 30 degrees, you consume less power because that's easier for your compressor to run. And so that's a type of flexibility we designed into our solution. So we can now use our machine and cool a chip anywhere from 50 to 30 degrees C. And that machine itself can be deployed. It could be deployed in a Scandinavian country with very cold ambient conditions, or that exact same machine can be deployed in Dubai under very warm ambient conditions. And so it allows our customers extreme flexibility. They could standardize on a design. So, and if they standardize on that design, whether they're building their data center in Phoenix or in one of the Nordic countries, that same machine can be deployed in either of those applications and run ultra efficiently without any modifications or changes.
It's absolutely incredible what you've achieved here. And I think your mission to bring efficient and sustainable tech options to data centers developers all around the world is incredibly cool, pun intended there. But it's also a refreshingly optimistic, proactive approach and a break from all the doom and gloom that we see on our news feeds. So just continue on this optimism here. How do you see these tech trends impacting the overall future direction we're taking, and what makes you most excited about this path forward?
Well, I think like any new technology, I think there's always concern about what is the future going to look like with this new technology being deployed. I think the reality, though, is history has taught us that every one of these technology evolutions has created a larger economy with more opportunities for employment, not less, with ability to perform tasks more efficiently than you did before. And again, as Johnson Controls, we're trying to utilize these same technologies to our own advantage, right? How are we deploying AI in our manufacturing plants so that our workers in those plants could become more productive and more efficient in what they do? How are we using AI in our design resources so that we're now rapidly increasing time to market for new products, because AI is allowing us to have more accurate modeling of compressor maps and entire heat transfer loops, allowing us again to deliver newer technology quicker to our customers. And so I think, and then overall, from a market standpoint, as technology becomes less expensive, typically more people are going to want to utilize it. And so overall demand is going to continue to rise. And I think that's what we've seen in data centers. So, if you go back and a news story breaks like, the efficiency of DeepSeek that came out, over, a few months back now, there was concern, does DeepSeek mean that a bubble is bursting in this data center boom? Well, what we've seen since then is, of course, the exact opposite. We continue to see increases in demand and workloads. And I think because the evolution is going to make AI more efficient and then less costly for consumers, I think that'll only continue to drive demand up for those technologies. And so I think, as a company, we've embraced it. Our customers are embracing it. And I think then what that means for a company like Johnson Controls is what we have to then come to grips with is that the solutions we're providing today are not going to be the solutions we're providing 4 or 5 years from now. And so our ability to continue to innovate and provide new technologies is going to be key, not only to the next 100 years of success at Johnson Controls, but really even the next 5 to 10 years of success in the company.
Well, thank you so much for sitting down with me, sharing your insights and the exciting work that you're doing at the moment. And before I let you go, I want to ask you to leave one final gift to everyone listening, and that is a book that we can add to our Amazon wish list. We've got our own little book club. I asked my guests to add a book to that they would recommend. So what would you like to add and why?
Well, so the last book I read, and I actually reread it, and it's not an impressive task to reread this book because it's extremely short, but it is an incredibly powerful book. It's called Og Mandino's The Choice. So the title of the book is called The Choice. The author is Og Mandino, and he takes this character through really a whirlwind of emotions, and the book itself is really about trying to make life decisions to balance yourself between an ambitious career, family responsibilities, social responsibilities, and how this character comes to, wrestle with these choices in his life. And there's some fantastic life lessons that I'm sure all your listeners would enjoy reading if they haven't. And again, I'm not pushing the book, but it's an incredibly easy to read book. It's a one night, read book. If you're on a 2-hour plane ride, you could read this book. Again, Og Mandino's The Choice. And I'd love to hear some of the feedback from some of your listeners on the book.
Oh, wow. I'm going to get that added straight to our Amazon wish list so people can check that out. And I think the big message today, computer chips are becoming more powerful, but they are generating more heat. And we need to spare a thought on the engineering teams like yours that are helping keep these chips running efficiently without overheating. It is a huge challenge. For me, it was just great hearing more about the technology that's making it all possible. And it's the kind of things that goes on under the hood that we take for granted. And hopefully everyone listening has taken a lot away from our conversation today. But just thank you for shining a light on this.
Thank you, Neil. Thanks for having me.
So, quick question. Did today change how you picture the cloud? Knowing that it runs on clever physics and even cleverer cooling. I think Todd reminded us today that performance, efficiency and sustainability can all move together when you design for all three from the chip to the atmosphere. And the takeaway for me is simple. Faster chips demand cooler thinking. And the winners will be the teams who plan for heat as carefully as they plan for compute. And as heat waves predictably will roll on, the smartest upgrade might be the one that you never see, quietly pulling kilowatts and degrees out of the equation so your AI can do real work. And if that's the future of data centers, what small move could your team be making to run cooler, use less, and go faster? Food for thought indeed. Tech blog writer at Outlook.com. Neil C. Hughes on LinkedIn, X, Instagram, etc. And Tech Talks Network if you want to listen to 7 other podcasts just like this one. And yet, I'm afraid they all contain me. Sorry about that. But I'll be back again tomorrow with another episode. But thanks for listening as always. Bye for now.